Okay.
All right, can I start?
Yeah, go for it.
All right, so hello everyone, welcome to the UGPN webinar series. I am Marco Aurélio Franco, assistant professor at the University of Sao Paulo, and I will be your host today. Next slide, please. These seminars will run until May 2025, which occurs on the first Wednesday of every month. In general, we have two speakers talking about their expertise. As you can see here on the right, our webinars are recorded and can be found on the GCare YouTube channel. Okay. Just a brief overview of the project. The project is led by Professor Prashant Kumar from University of Surrey. He is also the director of the GCare. Our project has around 45 members from University of Surrey, of Sao Paulo, and North Carolina State University, together with experts from different countries like Brazil, UK, China, and Australia. Our focus is the advance of nature-based air quality solutions to mitigate urban environmental challenges. It's worth mentioning the project's key objectives. So they are establish a global UGPN network for nature-based solutions in urban areas, create cases studies to tailor nature-based solution prescriptions for cities like Sao Paulo, Raleigh, and Guilford, facilitate knowledge exchange through staff, student mobility, and produce joint publications and new proposals for international funding opportunities. Next slide. Yeah. So today we have two experts on their fields. The first speaker is Tiana Elame, CEO and founder of EnvAns, and the second speaker is Rafael Bessa, Loureiro, PhD student at the University of Surrey. Each speaker has about 10 to 20 minutes for their presentation, and after we welcome everyone to make questions. Those questions can be, you can just write them in the Q&A box up there in the presentation box. So just a brief overview about our speakers. Tiana Elame is the founder of Environmental Answers, an innovative startup that focuses on environmental education, sustainable development, and clear energy deployment. Tatiana's most recent endeavors have led her to be an active member of her grandparents' historic neighborhood, which has been designated as an urban heat island. Tatiana's presentations will highlight the role of environmental education in creating more climate-resilient communities. And Rafael Bessa Loureiro is a PhD student at the People-Centered AI Institute, supervised by Professor Dr. Eric Sperandio and co-supervised by Professor Dr. Prashant Kumar and Professor Dr. Liang Kui. His research focuses on sustainable foundation models for time series processing applied to sustainability, developing AI models to address key environmental challenges such as predicting extreme weather events, monitoring air quality, and forecasting renewable energy. His work promotes responsible AI aligned with the UN's Sustainable Development Goals. So let's start with Tiana Elame. Please, Tatiana, welcome and thank you for your availability.
Hi, everyone. Yes, thank you. I'm getting my presentation shared now. Great. So yes, thank you for that warm introduction. Hello, my name is Tiana Elame. My presentation is on the deployment of environmental education to uplift community in an urban heat island. So the purpose of my presentation today is to highlight the program being implemented in the city of Raleigh in North Carolina, which is located on the east coast of the United States, the southern half, to highlight also the long-term benefits of deployment of environmental education, which ultimately leads to more resilient communities. So how today's agenda will go, I will introduce myself and Environmental Answers, EnvAns for short. I will talk a little bit about Southeast Raleigh, specifically the area in which has been designated an urban heat island and what is that, like a one-on-one, and then highlight some active environmental answers or solutions that are being processed here in the city of Raleigh. I'll also look at some key points, the current community engagement projects in Southeast Raleigh, then actively looking at what is community resilient. Then I have some acknowledgements, and then it'll be open for the Q&A. So let's start with who am I? My name is Tiana Elame. My maiden name is Jones. I'm an 8th generation North Carolinian. I'm descendants of slaves here in the United States. I grew up in the Washington, D.C. area. I possess a Bachelor's of Science in Environmental Science from the University of Maryland Eastern Shore, a historic Black college that is on the Eastern Shore of Maryland. I obtained a Master's of Environmental Management from Duke University, specifically their Duke Environmental Leadership Program that's designed for mid-career professionals who are in leadership roles and desire to excel further. During my matriculation at Duke, I developed a startup called Environmental Answers, EnvAns for short. It's supposed to be like a play on words. If you say it quickly, it sounds like advance or advancing us. But the goal is to help with this transition for us to put the environment first when we're thinking about industrial initiatives, basically thinking about how individuals interact with their environment. I included a photo of me at 7 years old here on the right side of the screen with my grandmother. She actually recently passed in February. I have decided to designate this presentation or dedicate it to her. The big, large trees that you see in this image, they actually don't exist anymore. They took them down because of power lines and the needing for accelerating the development in the city. So this is roughly like 25 plus years ago, and these trees were up. That area now doesn't have this tree canopy cover, so it's a lot hotter there, but just having these images as a nostalgic point reminds me of like positive summers where it wasn't as hot as it is now in Raleigh, and me being able to really see the difference when it comes to tree canopy. So Environmental Answers, like I said, it's a nationally and internationally recognized organization. It provides systematic solutions that effectively help to implement change for the long-term benefit of our planet. I host a biweekly podcast web series focused on interviewing different industry leaders, specifically from like, there was an example of a chef to someone that's working in like plastic development and how there's an overlap and how we need to embrace the connections between sustainability. I do consulting, historic preservation, and product development. If you're interested in learning more about EnvAns or about me, you can visit envans.org and learn more about the team that I have. So a little bit of background about Southeast Raleigh. Like I said, my family has been in North Carolina for 8 generations. On the left, this is a photo of my dad and my grandmother and my grandfather in front of the house that I showed you guys earlier with the like trees or whatever. This is back in 1968 when my dad was a little guy. But a lot of different African-American communities that were settled outside of the city of Raleigh started to move towards the city as it was developing. Most notably, my grandparents, one was a teacher in the regular high school education system. My grandfather actually taught education in the prison system here in Raleigh, North Carolina. They lived in Franklinton, which is about 45 minutes north of the city, and they were able to move and help establish one of the older neighborhoods in the Triangle. It's called Bitmore Hills. It's actually a historic neighborhood. It's going through its designation. If you're interested in learning more about the Black historic neighborhoods of Raleigh that haven't really been written about yet, you can check out this book by Carmen Cuthers. It's a really good resource. This is an image of coming in from the south side. It's one of my favorite ways to come into the city of Raleigh. You'll be able to see it, but just it's a beautiful city. So the definition of urban heat island. An urban heat island is defined as occurring when temperatures are higher in an area than the surrounding rural areas. So for example, when I think about Franklinton, which I told you is about 45 minutes, it's significantly cooler there sometimes than it is in Raleigh just because of like pavement. There's more tree cover there. There's a lot of less population density, and all of these things contribute to like the temperature rise. Raleigh is one of the cities, but not the only cities that's experiencing this, but it's due to accelerated growth, so development. Some of the shared environmental answers that are being actively implemented in Raleigh to combat the urban heat island effect is tree plantings, green infrastructure projects, and community-based education. I'm going to highlight some of the projects next, and if there's any questions about these at the end, I would love to hear from you. So let's zoom into Raleigh specifically. I have two images here. One is on basically seeing like these little heat images that are pulled in. This is pulled from the Triangle Regional Resident Partnership Alliance, like as an assessment of like seeing how some of the lighter colored areas, specifically the light pink, is not as hot as like you would see like Raleigh. And then you zoom in further on the right-hand side of the screen, you see Raleigh zoomed in a little bit further. There's an image where that has all the different degrees. It is in Fahrenheit, but like the temperature where there's a lower number, there's tree density. So it's something that's really important to note when it comes to combating, just like the temperature, we can use things like tree canopy. This, again, is not an issue that's unique to Raleigh. All major cities throughout the world have been combating different temperature issues when it comes to deforestation, the use of tar, and different materials that absorb heat. And without the long-term consideration of impacts. So one of the projects that's being implemented in Raleigh that's promoting environmental education and also creating community is the Street Tree Equity Project. It's an opportunity for residents in Southeast Raleigh to learn about the purpose of street trees and equity, like in a way that allows more people to contribute to it. Something that's interesting about this particular project is that they set it up so that people could come and see what trees and learn the benefit. So one of the images that they shared was this one right here, where you could see this is Chavis Heights, which is a popular park right outside of Raleigh in the southeast area. Main point is that you can see that the tree temperature, just from the thermal image, is cooler than those areas that aren't as covered by trees. But it's important because projects like this allows people in the community to contribute to what's being done around them, and you're educating them on the benefit of keeping the trees and how it's not just for aesthetics, but also has a benefit when it comes to climate resilience. Another project that's being done in the city of Raleigh is green infrastructure projects. I wanted to lean in specifically to the Bailey Driveway Getaway, expanding access to green spaces. The point of this project, again, this is located in Southeast Raleigh, is to help with connecting people to green infrastructure where there's tree canopy, but not just trees, but more of like learning about the history of the park, the materials that are being put together. And this is all being done underway with the Conservation Fund. It will help get a gateway, which in the city of Raleigh, we have these areas where people can bike on, providing that more to the south part and helping people to know more about it. It's an opportunity for them to really engage with driving community in the Walnut Creek area, which is one of the larger water spaces that we have in the city of Raleigh. So the Walnut Creek Learning Network, they have what's called a 7-week learning program, and it's an incentive-based education program, and it's community focused. I was a beneficiary of this, the most recent cohort, but they go through and teach different areas of education. One of them was ran on urban heat islands, and the benefit of this is that there's different people from the community that may not have environmental background, so it's open to everyone who applies. If you apply, I feel like most people get in, and it's not limited to any age or any demographic. I see people I saw 6-year-olds in the same classroom, and we're all learning together about our community at one time, and people were able to then be challenged to create a community project. So in order to finish this particular program, through the incentives of being able to get, I think there was a stipend associated. People were getting a stipend of I think it's $400, and then they were able to go through the 7-week training, see the same people for 7 weeks, learn the same information, and then over that time period, be able to create a community project that they were able to go and implement in the community right there. So it's leading to a way of connecting people to the environmental education through a way that is less serious or intense, but it's something also positive and informative. So in all, the deployment of environmental education to uplift community is a critical need for our shared future. And when I say shared future, I mean the future not just of being you, but that of maybe children or children's children's and children's children. Because I recently, I shared, my grandmother, she passed away in February, and I had a son in August. And so understanding that her knowledge of the environment was important because she was a teacher and she was able to spread knowledge and awareness. And then now it's my turn to spread that knowledge and awareness to my child and future generations. So in conclusion, having the opportunity to put this type of information out is critical. I wanted to say some special acknowledgments specifically to the city of Raleigh. It's really important that we have projects like this going on to let everyone, no matter their background, have access to information and knowledge and contributions to their area so they can feel empowered and have access to being able to implement information that they learn. So having programs like the watershed to be able to put that out there for people, it's important. I would like to also highlight the Partners for Environmental Justice, specifically Dr. Angela Allen and the Executive Director, George Jones, for the work that they've done to make sure that people are more aware of the watershed, all the NC State faculty. I would also highlight the Bitmo Hills Association as a resource for understanding the importance of documenting the history of neighborhoods in the Raleigh area in order to uplift community and educate so that we can have more resilient environments. I mentioned Carmen Cuthers earlier, but I would like to also uplift Mary Rampant Hanbury, understanding that the preservation part is connected to our environmental part, which allows people to be educated on their history. Like I said, my son, Msongo, my husband, Werlin, my grandmother, and all my family and my ancestors, because without them, I wouldn't be able to be here to talk to you guys today. And these are some of my references. And now I would love to open it to Q&A because I do like the idea of being able to talk to you guys about what I've learned and been able to share.
Many thanks, Tiana, for this very inspiring presentation. And let's move to the next presenter, Rafael. So in the end, we can read the questions. So Rafael, please, you have the word.
Yes. Can you see the presentation?
Yes, perfect.
Great. Thank you for the introduction, Marco. I'm going to present a work called Deep Neural Networks and Wavelet Augmentation for Predicting the Impact of Green Infrastructure on Urban Air Quality. Okay. So a brief introduction. 9% of the population nowadays, according to the World Health Organization, are breathing polluted air. In those pollutants, one of the really relevant ones, or the worst ones, are the PM 2.5, particulate matter, really small particles that can penetrate deep inside the lungs, the bloodstream. They can cause respiratory and cardiovascular disease. And one way to naturally trap or remove those particles from the atmosphere is through vegetation. So the idea here is to have a way to strategically place green barriers, in a sense that hedges, low level vegetation, so we can improve their quality by reducing the pollutant levels. This is an image for a green barrier from one of the sites that are going to show the data. And that's what I mean. We have a green barrier near a road where the cars are passing through, and the wave of pollutants comes through, comes out of the car as a hot air, gets colder, and then it will spread through the path where the people are walking through, where the pedestrians are walking through. So the whole idea is that placement of these green barriers are critical. They can even worse the pollution in some cases, and they have a cost associated. So our challenge is to identify the optimal location to maximize the reduction of air pollution. And our solution is to propose a model that can predict the impact of installing the green barrier near a road to reduce the PM concentration. This is our data setup or collection setup. We have one sensor in the roadside where the pollutants that come from, one green barrier that will reduce the pollutants, and another sensor in the pedestrian side. And the idea is to develop a deep neural network that can predict the PM concentration in the pedestrian side, only looking to the features on the roadside. And the idea is to predict it up to 24 hours in advance. And we also want to ensure that the model is adaptable and it can be used across diverse urban environments. So not only in the same location as the data was collected. With this respect that in a new scenario where we want to evaluate if a green barrier would be beneficial or not, we can just use one sensor with the roadside and our model already trained. Using the collected data from the roadside, we can predict or simulate how much it would be reduced in the pedestrian side. So we have a very long methodology here, but basically we define your use case, do some data preparation engineering, we do augmentation with wavelets, select the models, or methodology for evaluating those models. Then we hyperparameter the models to ensure that's on the best architecture possible, train them, evaluate the performance, compare them, select the best one, and have the final analysis of the results. In our specific use case, we use data collected by the educare group in the University of Surrey. Here in Guildford, each data site, each station, has the same architecture that I showed before. So one sensor on the roadside, the green barrier in the middle, and the sensor in the pedestrian side. And I have two separate sites in two parks with a road nearby. Those parks have a similar traffic congestion patterns, but what we do to increase the generalizability, the ability of the model to generalize, is to train using only one site, the site one here, and then evaluate or test our model on the second site with data the model never saw before. So all the results here are using the data that the model never saw before. In a bit of for data preprocessing, we have to average the data collected by each hour. So we have an hourly concentration. We match the timestamps of the two sensors. We have a way to convert the time attributes into the trigonometric representation. So the idea is to, instead of having only the continuous flux of time, we have a representation that represents the cycles in the data. In the end, we have our atmospheric data features, include temperature, humidity, pressure, PM 2.5, CO, NO2, and NO3. Those will be used for training in a collected from the roadside. And we also have the temporal variables, the hour, days, and month in sine cosine representation. We do outliers in noise handling, and we do data augmentation with wavelets. Just a brief explanation about what is wavelet. We have our time series with each of the features. We'll convert it into the frequency domain, extract some relevant features depending on the depth of the wavelet, so we can change that, and then reconstruct the signal into the original shape in the original size, and use it as another feature, another input feature. We use 5 architectures. As I said, we do hyperparametric tuning. What this means is we change different parameters of the networks, the size of the network, the number of layers, how much it looked in the past, and how much data augmentation to use. And we use those 5 architectures. Also a brief explanation of each one. The MLP is more of a classic deep learning approach, is a fully connected network. The convolutional network, when the CNN will focus on collecting local data, local features, extracting local features through convolution, and try to have a representation of the patterns in small time frames. The long short-term memory LSTM is the other way around. It remembers parts of the series and tries to have the feature, the recurrent features through a long time period. You have transformers. There's a newer model that focus on different parts of the time series and is good for the local and the global scenario. And we have a hybrid model that tries to take the best of the one CNN and LSTM to have also the local and the global, the long and short term features extracted. Okay. And for the results, we have 2 models. One is just for instant prediction. So we collect the data in the time step 0 and predict it on the time step 0. And the next one is for 24 hours ahead. So there is a lot of metrics here, but basically we have error metrics, correlation metrics, and interval confidence metrics. For our Horizon 0 model, the LSM was the best one in every metric. And we also have the consideration of the average inference time and model size. This is important because if you want to embed these models on a sensor in a small device, use it on the field, the model size is really relevant, and the inference time as well. So one consideration we can have here is that even though LSTM has the best metric results, if you need a smaller model, we can use the 1D CNN that is considerably smaller and has metrics that are not too far off of the LSTM1. And a view of the forecasting. So in blue is the original signal, the original PM2.5 concentration, and in orange is the predicted one. And you can see the model is able to follow the major trends in the data, but it still has some concerns about the peak data. So in the higher concentration, the peaks, it still fall off a bit. As I said, now the Horizon 24 model. So for this, we predict one time step, the 24 time steps ahead. And for the metrics, we average them and calculate the metrics. And here, the model was not so absolute, but the two best ones, again, was 1DCNN and LSTM. But the 1DCNN was better in most metrics, so we are considering it as the best one. And similar to the first case, he's the best model and is also one that is highly efficient. One key consideration we do is to evaluate how the model are predicting through the times. So not only the average, but also how the metrics are evolving through time. So just briefly here, the NMSE is one metric that I want as low as possible. And the 1DCNN here, even though he's not the best in every time step, he can keep a stable behavior through the hours. And similarly to the Spearman correlation metric, this is one as higher as possible, so as close as one as possible. Here again, it's not the best in every time step. It's second or third in some time steps, but it doesn't decline much, it doesn't variate much, it stays constant. And for the forecasting for the 0 hours to the 24 hours, the results are a bit worse the further we are from the original time. And we can see mostly on the 24-hour forecasting, we start to lose the smaller variations in the data. So, for example, in this section here, we average the small variation, but we still can get the highest change, the overall trend of the data. And also there is a bit of a time shift on the prediction. So the prediction starts to be delayed in comparison with the original signal. Okay. To conclude, we have proposed a framework, a deep learning framework that will enable us to have efficient and sustainable simulation of green infrastructure, impact on urban air quality, reducing the computational need, and supporting rapid and cost-efficient decision-making for urban planning. We can effectively predict the PM2.5 level after the green barrier using only the roadside data, and we can apply these models in new locations with similar environment and traffic characteristics. And lastly, if you want to improve this model accuracy, if you want a model that is more defined, we can do it through acquiring more data or more different types of data, including wind interaction and traffic patterns. Okay, that's it. Thank you for your attention, and I'll pass back to Marco.
Thank you very much, Rafael, for this very interesting presentation and results. So just again, if you have any questions for Tatiana or Rafael, please put your questions in the Q&A feed. We have one question here for Tatiana from Charlotte. Tatiana, what actions would you like to see in the future in Raleigh to improve tree cover and education around green solutions?
So I would like to see that a lot of the different parks that they have, the programming to expand to include the aging population a little bit more, especially in Southeast Raleigh. A lot of the neighborhoods are still occupied by seniors, and some of those seniors, the easiest thing for them to do when it comes to their trees, they would just rather someone like lop them down or cut them down, but explaining to them different techniques on how to do that, I think would be beneficial. Another thing I would like to see, I know for me, when the Walnut Creek Learning Center opened up, it's this center that's right south of the city. I was probably like maybe 12, 15, so like a while ago. And Main Point, they used to have it where like they had these days where people could come in. So I think there's different ways that they're getting that out, but if we can market that better to not just students, but maybe like to parents, especially early age parents. Like I have a 6-month-old, and I know a lot of times moms could get stuck in the house. So like having like programming that's a little bit after communities that often aren't necessarily top of mind.
All right. Actually, as you said about the heat island, many cities in the world are indeed facing issues with heat island, and I would like to add that São Paulo is not different, of course, and here we are facing these issues a lot. I have one question here for Rafael, but thank you very much for your answer. Rafael, what was the most surprising result of of your study?
Oh, surprising result. That's a different question. So if you go more in the technical side, we were expecting the transformer model to exceed to be the best one, as a new architecture, and it actually has pretty good performance on forecasting general time series. But didn't happen. The one that was the best was LSM on this NN. That for me on the technical side was the most exciting one. But more on the user case specifically, I think the ability of the model to actually predict well in the new site was the most relevant result, because that means that we are not only locked on the data we collected, and we can apply it at least on a general area around where we collected. So that makes it more useful for the decision making, for the actually beneficial side of the application of the AI. It's not only throwing data in and get some results out.
Thank you very much. Actually, Rafael, I really liked this analysis you are doing. I'd like to make a quick and a more technical question about the features you are using for your model. Why did you choose to use the sine and cosine of the hour, month, and so on? How does it help to improve the model?
Mm-hmm. Again, to also be a bit more technical answer, right? So how the data is represented normally is, for example, if you have a 24-hour horizon, 24-hour in the day, when you go from the hour 24 to the hour 0, we are getting a 24 step back. But this doesn't actually happen, right? It's like 0 to 24 and then 0 again, or 1 again, right? So the idea of the sine and cosine is to, instead of having this step or this representation, this distributed representation, we have actually a representation of how the time passes. So we have a cyclical representation, and after we end the day, we will start the new day in the same point. So that is not the data itself are not as if it was blocked in different times.
Mm-hmm.
That's the idea.
That's great. Thanks.
And just to be fair, this is not my idea. It's from another paper, okay? But this is a common way to model time series.
All right, thank you. We have another question for Tiana from Meredith Martin from NCSU. Hi, Tiana, great presentation. I have a similar question, which is to hear your perspective around resistance to tree planting due to perceptions of cost around maintenance and other issues related to trees causing damage to cars or houses, etc.
Oh, no, I appreciate that question, and thank you for the compliment on the presentation. In 2023, I had the opportunity to travel to Singapore to look at like some of it's a biophilic city. So going and traveling to some of these biophilic places where they're like desiring to use like trees and greenery as a way to cool and keep the temperatures low. My first thought is that, it needs to start with the beginning of how we're building the spaces so that, maybe not where cars are right over houses might be the exact place a tree might be planted, keeping that stuff in mind. A lot of the things that we're challenging at Environmental Answers or EnvAns is that whole thought of like the environment needs to be a part of the first thought as we develop projects and implement it. So when it comes to like the resistance, my challenge would be back to, well, what is the purpose? Why are we considering it? Is the goal just to plant trees for the sake of planting trees? Or are we planting it with the intention of tree canopy to cool things? And if so, how can we design it in a way that it integrates with the systems that we've created? So making it so that we have a more integrated connection to how we're working with these things.
All right, thank you very much. Is there any other questions? I don't see them here. Well, so, all right, I think we can just thank you a lot, Rafael and Tiana, for your very nice presentations, and also thank you for being here during our webinar today, and just presenting the next speakers. They will be the webinar will be in April 9th, April 2025, and the speakers are Dr. Mario Gavidia Calderon. It's a researcher here in University of Sao Paulo. He works with heat waves, and he will give a lecture, seminar about heat waves and air pollution in the metropolitan area of São Paulo. And Sohelia Khalili, she's a PhD candidate in the care, University of Surrey. And the theme is quantifying the co-benefits of urban parks in terms of heat mitigation and air pollution. All right, so thank you again for being here and looking forward for the next seminar. Thank you.
Thank you very much.
Ciao, ciao.